Hi, Olivia. This is lesson 4142. I want to go over this with you. It looks to me like you understand how to do these. For whatever reason, you just did not put it in the right format here. And also, this was originally marked wrong. I just marked it right because you didn't put the period behind the letter N. Remember how I say all the time, IN without the period is just a preposition. If you don't put that period in there, that could be the only thing that makes it mark it wrong. And that's what happened here. So I manually marked it correct, but be sure to put that period in behind it so that you get that confirmation. Okay. So go back and look at this one in order, because it looks like you know what you're doing. You just need to put it in the right format. All right. Estimating the product. So this is scientific notation, and we are going to estimate in multiplication. So we have 13 times 5,280 times 5,280 times 12 times 12. And this looks an awful lot like the previous problem we just did, only we have a 13 in front instead of a 30, and we have squared area instead of volume. So we're going to estimate and find the answer here. Now, typically when we estimate, we round to 1 decimal place. So what we're going to do is we have 1.3, which would be rounded to 1. And in order to take it to the ones place, we have to move that decimal back 1, right? So that's 10 to the 1, right? So that's that first number. That second number would be 5.2. We cannot round that up to a 6, so it stays a 5 times 10, and we are going to move the decimal 1, 2, 3 places, so 3 places. Same thing for this one because it's the same number. And this 1.2, we're moving it to scientific notation. 1.2 doesn't round to 2, so we just say 1 times 10 to the 1, and the next number 12 is the same, so 1 times 10 to the 1. All we did was we moved our decimal to 1 decimal place. We moved our number to 1 decimal place, or the ones place, and everything else is a decimal. And then we rounded it, right? We rounded it. So that would have been 1.3 times 10 to the 1. That's what 13 actually turns into a scientific notation. But when we round it, it's just 1, right? So we are rounding our numbers. We are getting rid of any decimal places and just using whole numbers to estimate. 1 times 5 is 5. 5 times 5 is 25. 25 times 1 is 25, and 25 times 1 is 25. So our answer is going to be 25 times 10, and now we just add the exponents. 1 and 3, that's 4, plus 3 is 7, plus 1 is 8, plus 1 is 9. Well, guess what? That's 2 places. We only want 1. 2.5 would be times 10 to the 10th place. But we don't want to do 2 decimal places here. This is fairly accurate, but what we'd rather do is round it. So 3 times 10 to the 10. This is an acceptable answer, but this is a better one. All right? Because that follows the format of everything else we've done. Does that make sense how we're doing this? All right, we're going to do this one, and we're going to estimate it as well. So let me clear this page. All right, we have 4, 3, 5, 3, and then 9, 3, 3, 2, 1, 6 times 10 to the negative 11 over 319, 214, and then 0.01603 times 10 to the negative 31. All right, so first we're going to put this all in scientific notation rounded, right? So this rounded, well, unrounded, it'd be 4.353 with a ones place only. and that would be 1, 2, 3. So times 10 to the 3. So we round that decimal, and that becomes 4 times 10 to the 3. See what I did? This would be 9.33216. 1, 2, 3, 4, 5. That'd be a plus 5. So times 10 to the negative 6, because we combine those. We round this down to the whole number. That becomes 9 times 10 to the negative 6, right? So far, so good, right? Now this would become 3.19214 times 10, and that would be 1, 2, 3, 4, 5 to the 5. But we round this to the ones place, and that becomes 3 times 10 to the 5. Easy peasy. All right, this would become 1.603 times 10, and because we move the decimal place back 1, 2 places, it's going to be minus 2. So that is going to be 1.603 times 10 to the negative 33. And because this is 1.6, the 6 is greater than 5, so we round that whole number to a 2 times 10 to the negative 33. Now we do the math. 4 times 9 is 36 times 10. 3 minus 6 is a negative 3. 3 times 2 is 6 times 10. We have 5 and a negative 33. That's going to be a negative 28, right? Okay, so now we divide. 36 divided by 6 is 6 times 10. And when we move this to the top, this becomes a plus 28. So this is going to be a positive 25. 6 times 10 to the positive 25, which is what we have here. All right, it's not so hard once you figure out the pattern. There is a pattern. You want a ones place only, everything else left is a decimal, and then you just figure out which way. If this is a bigger number and you're making it a decimal, a smaller number, we add the exponent. If it's a smaller number that you're turning into a bigger number, we subtract the exponent. Okay. All right, let's do one more. Number 6. We have 0.013, and that is the negative 12. And that's a positive 21 over. All right, we double check, make sure I wrote everything down right. 0.13926. Okay. All right, so I'm going to shorten this up. So this would be 1.3926 because we have to have a ones place only. And I'm moving it back 1, 2. So it's going to be minus 2. So when I round this, this is less than 5. So that's going to be 1 times 10 to the negative 14. This would be 2.7153 times 10, and I'm moving this 1, 2, 3, 4. So that's plus 4. So that's going to be 2.7 will round up to 3. So 3 times 10 to the 25. Because 21 and 4 is 25. All right, now down here, that'd be 6.354 times 10. And that's 1, 2, 3 plus 3. 31 plus 3, that's going to be negative 28. So 6.3 does not round, so that's just 6 times 10 to the negative 28. Multiply is going to be 3 times 10, and I add the exponents. That's going to be a positive 11, because negative 14, positive 25, over 6 times 10 to the negative 28. 3 over 6 is the same thing as 0.5 times 10. When I bring this up to the top, it becomes a positive 28. So that's going to be a positive 39. But I want to bring this to have one, we have to have one whole number here. So this is going to go back 1. So we're going to minus 1. So that's going to be 5 times 10 to the 38 as our final answer. All right, I hope you're seeing how to do the estimation. It's all about whether or not we can round that decimal to a whole number up or not, or leave it the same. Okay? Let's clear this. Let us look at number 7. We actually went over this one, I think, in study group. You may have already left. I don't know if you had a chance to go back and fix this. Obviously not. So let's do this again. All right, Freon 12 is this right here. That is the I can't speak. That is the chemical composition for Freon 12. All right, that equals that. What we need to do is figure out how much carbon is in a certain quantity of Freon 12. We have 1,200 grams of Freon 12, and we need to know how much carbon is in that. So we need to break this down into its components. So carbon, it tells me right here, is equal to 12 grams. And there's only 1 gram of carbon. When there's no number, it means 1. So times 1 is equal to 12. Right? This is our rate. Chlorine is equal to 35. And there are 2 chlorine atoms. So that's going to be 70 grams. And then the fluoride, or fluorine, whatever that is 19. And there are 2 of those. So that would be 38. So now when we add that together, we get 0, carry 1, that's going to be 120. Now we are worried about how much, there's a total here of 1,200 grams. This is our total in this chemical solution. So it's kind of like baking when you have a recipe that says, you know, I need 1 part sugar, and I need 2 parts flour, and I need 3 parts, let's say, I don't know what would go in there, 3 parts water. Let's do water, 3 parts water. So maybe you do cups here, maybe do tablespoons here. Doesn't matter. That doesn't matter. We just have the value or the percentage. Actually, this is the better word, is the fraction of what goes in each. We've got 1, 2, 3, 4, 5, we've got 6 parts total. 1 of them sugar, 2 of them flour, and 3 of them water. So we have it broken down into the quantity. And then it tells us, well, if I have 6 parts here, but then I've got a total over here of 18 parts, how much of it is sugar? So basically what we have to do is figure out the ratio of increase from here to here. And if we look, 6 times 3 gives us 18. So 3 times 3 would be 9, 2 times 3 would be 6, and 1 times 3 would be 3. 3, 6, and 9 equals 18. So that means we did it right. So it's kind of like finding a scale factor of 3 here. Well, here, if we look, we know that the total here is 10 times the total here. And we need to know how much carbon is in it. So we could easily do this, right? And figure out that we have 120 grams of carbon. Really easy. The problem comes in when we can't see the percentage or the scale factor, and we don't know how to do that number in our head, right? Like for instance, if I had needed a different quantity here, like maybe the quantity was 638 grams, I can't find that scale factor just by looking at the number. So the way we would do that, we would set it up. We don't care how much chlorine is in there, and we don't care how much fluoride is in there. We're worried about carbon versus the total. So the amount of carbon versus the chemical composition is 12 over 120. Then, I'm going to do this. We put an X next to what we're looking for, which is the carbon, over the new total, which is 1200. Then we multiply. So that'd be 120. We cross multiply. 120 times X is 120X. 12 times this is going to be 14400. So when I divide, I get 120. Easy peasy. We can do that in our head, right? This is pretty easy math right here. What if, so that's the answer, is 120 grams or 120 G. I even took 120, but that's how you find it. What if this was not 1200? If, let's say that I had, let's say that I had 1700 grams. I can't figure out, that ratio is not times 10 anymore. It's times some number I can't do in my head. I can't see. I know it's going to be greater than 10, but that's about all I can figure out. So if you set it up the same way, it doesn't matter what this total is, you're going to get it right. 120x is equal to, and now we just pull up the calculator. 12 times 1700 divided by 120 is 170. X is equal to 170. I wouldn't know that though if I didn't do the math. That's 170 grams of carbon. Right, so you've got to be able to understand how to set up the proportion. It is this, but sometimes the numbers just don't line up for you to do an easy scale factor, and you've got to do that proportion and that cross multiplication. Setting it up like this, where you have a ratio, you understand the parts of your recipe, because that's all chemistry is, it's just a recipe. You had 1 part of carbon, 2 parts of chlorine, 2 parts of fluoride or fluorine, whatever that gas is. And then you figured out the components, the composition of that. You've got the weight times the number of parts, or you've got the grams times the number of parts in each one, gave you the total amount. Just like we did here. 1 cup of sugar, 2 cups of flour, 3 cups of water gives us 6 cups of stuff. Right? And then we needed to figure out, well, if I have 18 cups of the same stuff, how much is sugar, how much is flour, how much is water? And you can easily do that using this method, this proportion method here. I'll show you here. What if I didn't know any of this? I could just put an X. Let's say I want to figure out the flour. So I don't care how much sugar and water is in it. I just want to know how much flour is in it. So 2 over 6, that's 2 out of my total of 6, is equal to how much out of a total of 18? Cross multiply. That's going to be 36 is equal to 6 times X divided by 6. We know 36 divided by 6 is 6. Our scale factor is 3. 2 times 3 is 6, right? So we got the right answer. We got the same answer as we did before. We just did it in a way that works every time. That's the important part. Understanding how it works for every time and not just when we recognize the numbers. But that's what we're doing. All right, so let's look at number 8. I know there were a bunch of people on the struggle bus with this one. And we did do this in class. When we do these in class, please go back and fix it. At least I think we did this in class because it's been 2 weeks. All right. We know that any, what is the word I'm looking for? Any 2 consecutive sides in a parallelogram. Consecutive means one right after the other. Any 2 consecutive sides in a parallelogram equals 180 degrees. So this one plus this one is going to equal 180 degrees. And the reason you would do this one first is because you can't solve for 2 unknowns without something else, another equation to compare them to. So by itself, we would have to do this one that has just the y in it because we can solve for y. So 8y plus 20 plus 10y plus 70 has to equal 180 because there are 2 consecutive angles in the same parallelogram. So when I combine 20 and 70, I get 90. When I combine 8 and 10, I get 18y plus 90 equals 180. I subtract 90 from both sides. I got 18y is equal to 90. Divide by 18y is going to be equal to 5. Now that I know what y is, I can solve here because I know that 8y plus 20 plus x plus 50 is equal to 180 because these are 2 consecutive angles within a parallelogram also. But now I know what y is. Y is 5. So I can say 8 times 5 is 40 plus 20 plus x plus 50 equals 180. So that's going to be 60 plus 50. That's x plus 110 is equal to 180. I subtract 110 from both sides. X is going to be equal to 70. So now I know the value of x and y. X is 70 and y is 5. Easy peasy. All right, that was 41, 42. I'm done with that. I'm going to send this to you, and then I'll do 47.